This video is not a recording of my lecture because I had some technical issues with the recording, but at the same time I thought it was a good thing because I can just start from the scratch, write a Pygame so that you can just watch this video to see how a game can be made in Pygame. Now, in your Python installations, depending on your version, you probably don't have the Pygame installed. In that case, one thing you can do is to do pip install Pygame, and that's going to install the Pygame. Some of you might have pip3. If this doesn't work for you, pip3 might work. Pip3 install Pygame could be working for you. And if that still doesn't work, then you might have a Anaconda version that you have to use, and that could be like conda install pip -c conda forge. You should run this first, and then you can install pip after this. Okay, so anyways, I'm going to assume that you've successfully installed a Pygame, so now we will begin writing a game in Pygame. When you have a Pygame, you first have to import the Pygame, of course. So import Pygame as PG, and I'm giving a alias for Pygame as PG so that I don't have to type the entire Pygame every time I need it. Now, I will be needing system for some reason later. I'm going to explain. And then in any Pygame, you start with pg.init. And let's define some constants. We learned in class that in Pygame, in Python, we don't have constants, but it's customary to define something in all capitals, and that means this is a constant that we shouldn't change. Okay, and then we're going to have a screen ready, and that's pg.display.setMode, and you have to put width and height. Okay, make sure you have two parentheses. The inner parenthesis basically builds a tuple and sends the tuple into this set mode function, and it's going to get ready a screen for us with a given width of 800 pixels by 600 pixels. Okay, now let's define some colors as well. Color black would be 0, 0, 0, and this is because we're using the RGB channels to define colors. So the RGB values are 0 through 255. 255 is the brightest. So if you put all the red and green and blue channels to be 0, then you don't have any light at all. That's going to be black. On the other hand, white would be 255, 255, 255. That's going to be white. Now, if I want red, then you would just want the red channel to be fully lightened up, and then the other two should be 0. Okay. Now, what can we do with this? Well, in order to understand what to do here, you first have to know how the Pygame screen coordinates are made. So Pygame screen coordinates are from 0, 0 for the top left pixel, and because it's 800 by 800, 800 by 600, this bottom right will be 800 by 600. Actually, it should be 799 by 599 because it started with 0, so this should be really 799 here and then 599. Okay. Now what you should notice here is that in Pygame, the x coordinates go from small to large as you go right. That's not unusual, but look at the y coordinates. So as the y coordinates increase, the points go down rather than up. So whenever you try to draw something, make sure that in this coordinate system, down is positive. Down is positive, and if you decrease the y value, that actually makes things go up. Okay, and now what I want to do is to put a circle on the screen. So let's see how that can be done. So we're going to do first we're going to fill the screen with black. Okay. And then we're going to draw pg.draw circle. It says it has surface, color, center, and radius. And let's make this, well, surface will be our screen. Color, let's make it red. Center, as I explained, because this is 800 by 600, if I do 400 by 300, it'll be somewhere at the center. And let's make the radius 20. And once you make everything ready, then you have to do pg.display.flip. Okay. So anytime you draw something, you have to follow this this order. You well, you have to fill the screen with something so that it has a background, or you can also use some background images. And then you can draw something on it, and once you have everything drawn and ready, you have to show that all at once on the display, because if you don't do it this way, then all the things that you're drawing will be done in real time, so it doesn't look like a movie. The idea is to draw things like a movie. You have a next screen ready, and you're just showing pages and pages of still images, but if you put the drawing slightly different each time, then they'll look like it's moving. Okay, so for now we'll just draw a circle in the center, and then that's it. So let's see what happens if we run this. Now if you run it, you're going to see this red dot. If you don't see this, then there should be some additional screen here. You can click this and it shows. Now sometimes this doesn't react properly. In that case, you may have to reduce this screen, minimize this one, and then when you minimize the spider, then this screen will be right behind it. Okay. Now you might see something here that's strange. It says not responding, and that's because I did not make a graceful exit on the Pygame. In such a case, the only thing you can do is you can press this X, and then the windows have trouble closing it, because it's Pygame internally. Once it initializes, it just runs forever until you send a quit signal to it. So I'll have to close the program, and the operating system will forcefully close it, and while doing it, it will actually destroy the kernel. So that's what's going to happen here. Okay, so how do I make it actually gracefully exit? Well, for the time being, let's just wait 5 seconds and then close. So to do that, we'll import time, and at the end, what we're going to do is time.sleep for 5 seconds, and then we're going to do pygame quit, and then also sys.exit. Okay, and if I run it, it's almost the same thing. Let's minimize this. Okay, it's almost the same thing, except after 5 seconds it just disappears, right? Okay, now let's try to make the ball move. As I said before, it's just a sequence of drawing the ball in different positions. Let's change the x coordinate slightly so that every time it's shown, the x coordinate will increase. That's going to make the ball move from left to right. Okay, so what we're going to do is do a for loop for I in range, and let's go from 200 to 600, and select this much, press tab. So now this much is inside the for loop, and we're going to change the 400 from 400 to I, and then every time we place it, we should do time.sleep a little bit, say 0.02 or something, so that it will show the picture and then stop for a minute. Of course, reducing this will increase the FPS, the frame rate per second, and the ball will move faster. Okay. All right. So let's see how this one goes. Let's run it. Okay, and we can see that the ball is slowly moving. If I reduce the time.sleep to 0.01, then it's going to be twice the frame rate, so it's going to move double time. After the loop is done, it's going to wait 5 seconds and it's going to exit. All right, good. So that's your first animation done in Pygame. Some of you may think this is neat. Some of you may think, oh, this is kind of boring. Well, if you think this is boring, let's make it move a little bit. So instead of doing it this way, we're going to start with some position x comma y. So we're going to say x is equal to, let's just put it at 400 comma 300. So we're just going to get x comma y equals to 400 comma 300. So that's going to be the initial speed, initial position. And we're also going to put the initial velocity and initial velocity, x and y velocity. Let's move it, make it move 3 to the right, and initially let's make it go up. So you know, as I explained in the Pygame display system, the minus is up and plus is down. So to make it go up, we'll put something minus. So let's make it -4. And then these balls will be subjected to gravity, so you want it to go, you want the velocity in the y direction to increase by gravity. So we're going to put gravity, and this will be some fixed value, so that's why I'm putting it as all caps so that it's a constant. So we have a constant value gravity as 0.3. I tweaked some numbers, and this seems to be a reasonable number. All these are not set in stone. You might make the ball go slower or gravity to be heavier or something like that. Okay, so that's what we want to do. And what I want to do is instead of making the circle appear at I comma 300, now we're just going to make it appear at x comma y. But if I don't do anything to x and y, then it's not going to move, right? So what we need to do is we have to modify the position, x position and y position by velocity. So at every frame, you're going to modify the value of x by x velocity. So when x velocity is positive, the x coordinate will be increasing by this value, 3. And the same thing for y. Y value will be modified by the y speed, y velocity. But then note that, no, sorry, it's x, not x3, but 3x and y. Note that the velocity in the y direction should also be modified by the gravity, right? So we'll add gravity to this so that the y velocity will be increasing, okay? Alright, so, and I thought the balls were moving too slow, so let's make this a 0.01, okay? Alright, so let's see what happens. Run it. Okay, so the ball went up and then just went outside the screen. And after some time, when the for loop is over, it's going to die out. Okay. All right. So it did do a parabolic motion, which is kind of neat, but if it's outside the screen, it's useless. So what we're going to do is we're going to make the ball bounce off the bottom end. So to do that, what we're going to do is we're going to say if the y value is if it's at the bottom is what 599, right? If the y value becomes bigger than 599, then we have to make it bounce back, which is the velocity of y velocity should be the negative of itself, should be negative of vy. So it bounces back. Right. On the other hand, it should also bounce back from the right endpoint and left endpoint. Oh, by the way, because the ball is radius 20, we should subtract 20 from here. So you know what? The best way to do this would be really say that height minus 20. That should be the value. If the ball is bigger than height minus 20, then it should really be height minus 21, but that's okay. It's not going to be much different. You might modify this to be 21 or not, okay? So if it's beyond the height minus 20, that means the ball touch the bottom, so it has to bounce back, okay? And then on the same way, if x is bigger than the width minus 20, then the velocity of x should be negative of velocity of x, okay? And then if x is less than 20, that means you're touching the left side, right? So in that case, you also want the velocity to turn back, okay? All right, so with this, the ball cannot escape the frame. You could also make the ball bounce off the ceiling, but the gravity is always pointing downwards, so it's okay for the ball to briefly disappear from the screen, because kind of what goes up must come down to the screen. So this is all we want to implement. Let's see what happens if we run this. Okay, great, awesome. Okay. All right, so and then we wait 5 seconds and it goes away. At this point, I think waiting 5 seconds is kind of distracting, so let's not have this. After the for loop is done, we will just exit, okay? Okay, so this is how you make the ball move. But at this stage, I want to explain what we're trying to do here. We want to do something like this. I want a spaceship down here, and the ball should be here, and then this will move left to right, and then it's going to shoot down the balls. That's basically what I want to do, but just having one ball is not so fun, so we'll have several balls bouncing around. And because already just to make one ball bounce around needed this much code, you kind of see that going from this point to an actual game is a huge task, right? That's where the object-oriented comes in. Right now, already this code is a mess because you have all these algorithms for figuring how to make the ball move that is with the other parts of the code, which makes it draw on the screen and it displays and you have to wait. So what we need are two things. One is we need to abstract away this logic to somewhere else in the code, so when you read this, it's easier to see what's going on. Another thing is you need to organize the code so that you can kind of see that what this is doing is we're doing the ball. Right now, it's really hard to see that what you're modifying is the ball's position and velocity, because we didn't name the variable as such, right? So it's actually really hard to make such a game without the help of object-oriented programming. OOP really shines when you have to make graphical games. Of course, there are other use cases where OOP really outshines the procedural programming. The type of programming that we've done so far is called procedural programming, and it works in many cases, but once your code logic becomes harder and you have many different things or many different actors working in the game, then it's really hard to do it without object-oriented programming. Okay, so now let's make everything object-oriented. Okay, so here we go, OP to the rescue. So what we're going to do is we're going to make a bowl class, and as with any class, you need to define the init, right? So let's make init, and then always when you make a method of a class, you need to pass on the self as the first argument. And what we're going to do is, let's see, the gravity can be over here because, let's put gravity over here, okay. So gravity is a global constant, so we're going to leave it that way. And then we're going to grab this much code and indent it into the code. Okay, so okay, maybe it's Python doesn't like the indentation here, so let me indent it. Okay, good. So now we've indented this, and okay, good. And then we're going to make these as our self variable, so it's a class method variable, no, class variable. Actually, it should be object variable. Okay. Object variable should be these, and so you've defined the self.x, self.y, self.vx, self.vy, all of these like that, and this much will now be moved into the class 2 by another class method called move. So we're going to do df move self and control V of that code that we just copied over. Right, so we had this code down here, right? I cut and pasted over here, okay? And now the problem is all of these variables now need self dot. So let's do self dot, but copy this much, Control C, and I'm going to paste it over to every beginning of the variable. All of these should have self in there. Self, 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 self. Gravity is a global constant, so that doesn't change. That's good. Okay, and this one self, 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 self. All right, good. Oh, this one too. Self. Okay, so we've made everything as self. That just modifies the position of the bowl accordingly. And since this is abstracted away into the class, down here all we have to do is make the bowl move, okay? All right, and then even this draw functionality, I want to put that into a single method. So what we're going to do is we're going to define another thing called draw self, and we're going to do pg.draw.circle screen red, and x and y should be self dot, so self dot x and then self dot y. Okay, so that's what we're going to do. There's one more thing that I don't like about this. It's that the screen is this one, which is outside the class, and this would end up being a global variable because when you do this, and then it's going to look at this one. So to go around this problem, usually global variables are terrible when you make bigger programs. The good thing to do is to pass the screen as a parameter, just like that. Okay. Another option would be to not do this at all, but just acknowledge the fact that this screen is indeed this screen, but we're never going to change what it means from this. So this screen will always be this guy on the right. So if you do that, then you might, another way to go about it would be to make this screen as capital, because although Python does not distinguish between global constants and global variables, there is no constant in Python. But if you put that as big capital screen, then it kind of gives an idea that that shouldn't be modified from here. So that's another way. Let's just put screen here. We just have to type a little bit more when you draw stuff, okay? All right, so now we have made a ball class. How do we actually use it? Oh, we're going to instantiate the ball by saying ball equals the capital ball, open and close. And then you're going to do ball.move, and then ball.draw, and we're going to draw it on the screen. Okay, yeah, because we've decided that the screen should be passed to the draw function. We have to put the screen here. Okay. Now what this is going to do is it will be doing the exact same thing that we've done before. Let me show you. It's just going to, oh, something's not right. Oh, non-type has no attribute move, okay. Ball.move. Oh, sorry, it should be class, that's why. Okay, class ball, and then now it instantiates. Okay, so I kind of forgot that this should be class. Okay, now everything should be fine. Okay. Right. So it's good. Oh. Okay, let's run it again. Yep. Does the exact same thing and goes away. All right. All right. Now it looks better. That's something that you should notice. That now the for loop, inside this for loop, the logic of the program is apparent. You paint everything black, and you move the ball, and when the position is obtained, the new position is obtained, you draw the ball at that position on the screen. And if everything is ready, now you flip the display to show everything that you drew. You wait just a little bit so that the viewer can watch it, and then you now prepare the next screen and flip to the next one. So that's very clear if you write it like this. It's much less confusing for a coder to maintain if they want to make changes, whereas the previous code, although it was slightly simpler, it really didn't tell much. You couldn't really see what was being moved. You had to run the program to see what's going on. Okay, so that organizes this, but you're probably not fully sold why OOP really helps here. And to sell you this idea, I want to say that you can make not just a single ball appear on the screen, but you can make several balls appear on the screen, and you can just work with those. Okay, so here's the idea. What we're going to do is we're going to instantiate the ball in some random position. So what we're going to do is import random. Actually, let's do this. From random, import. We're going to import randint, choice, random choice, and we can also import the uniform. So what uniform does is well, I'll show you how these are used. So first of all, what you want to do is the the positions will be chosen randomly. So the X position will be randint anywhere from 20 to 779. Okay, so the ball could be on the far left or far right, or you know what, maybe if it's too close to the wall it might not be fun, so let's make it a little bit inside. So let's just make it like between 100 to 699. Okay, so that will be the X position. X position will be randomly selected. And then self.y will be random. And we want to make it appear between, say, 100 to 300. Now, I don't want the balls to appear too close to the bottom, because then it might be too close to the spaceship, and the spaceship wouldn't have chance to avoid the randomly appearing balls. So this is what we want to do. Let's see. Oh, it's not random, but randint. Okay, so that's what we want to do. And then what we can do is, instead of instantiating a single ball, we will make a ball list of balls. So what we can do is like ball list as empty ball, and what we're going to do is like for, and let's also make the number of balls on the screen as a num balls as 3, and we're going to make a for loop for I in range of num balls. So if you do that, you can loop through, execute the instantiation of the ball several times, and every time you instantiate, you can make it to be included in the ball list. So what we're going to do is like ball underscore list dot append a new ball class. Okay. Now, if once we do this, then Python complains because we don't no longer have the ball. So we are going to have another for loop here. So for ball in ball list, and we can take this much and shift, just do tab in there, and then what we're going to see is that we're going to not only have a single ball but several balls moving on the screen. So let me show you. Yep. So several balls are moving on the screen. Okay. Now, one problem is that these balls had the same initial velocity in the x direction and y direction, and that's not very good. We want them to be going in different directions. Okay, so we'll also make this random as well, but because the velocities could also be, see, positions, it's good to have integers because those are pixel positions, but velocities, it doesn't have to go by integers. You can have some decimal values too. So this is when we're going to use uniform. So for example, self.vy, we're going to use uniform, random.uniform, to be somewhere between -4 to +3. Now I don't want it to be thrown down. 3 is downwards, okay? Negative is upwards. So upwards, -4 is fine. I think even -5 is fine. But if it's initialized and it's thrown hard downward, then the spaceship might not have time to avoid it, so it's not a good idea. So I'll limit the downward velocity to be at most 3, but upward velocity can go up to -5. Okay, so that's y velocity. And you might try to do the same thing for the x velocity, say from -5 to +5. But there's a problem with this because then the velocity might be too close to 0. Then in that case it might not move much left or right, and it just bounces in its place up and down, and that's not very fun to look at. So instead of this, what we're going to do is we're going to make it go from 1 to 5, but then multiply it by choice of either -1 or +1. Okay, so 1 or -1. So when -1 is chosen, then this value will be multiplied by -1, which means you have x velocity in the negative direction, which means the ball will move left. If this value is, if choice is 1, then this value will be positive times 1, which is a positive value, then it means the ball will move right. Okay, so that's going to instantiate balls with different velocities, so it'll be a lot better to look at. Okay, so you see that these are very random in their initial behavior. But still, another thing that I don't like is that the balls are all red, so it's hard to distinguish them. And besides, it's ugly to see just red balls. So let's make a new variable called self.color. And self.color will be rand int. I have to provide RGB channels, but if I start from 0, if the value is too close to 0, and it will be black and it will be hard to see. So let's make it at least 50. Right? So I'm going to copy this, Control C, and then comma Control V, comma Control V. So that's going to give you the color, and that color will be replaced over here. We're going to do self.color, and now let's run it. Beautiful looking colors. The balls are moving wildly. I think that's a little bit fast, so let me change this to something 0.012. Okay. And of course you can tweak these values, and I guess if you make it go slower, the game will be easier to play. If this is very small, then the things will move fast, so the game will become harder, right? Okay, so we have this. Now we need to start drawing the spaceship. Now how do we do the spaceship? Well, you do the spaceship much like how you did the class ball. So what we're going to do is we're just going to copy this class ball and now make a spaceship class, because it'll be pretty much the same thing. So I'm just going to rename this as spaceship, our main player. And my x coordinate should be center of the screen, so I'm going to make it width divided by 2. On the other hand, for the y coordinate, I want it to be somewhere at the bottom, so I'm just going to do height minus 50. That's like at the bottom of the screen. And the spaceship will only be allowed to move left or right, so we're not going to have Vy. And initially I'll just make it move right, so I'll just put it as 5. Okay, and the color should always be white, so it's easier to see. And because it's not subject to gravity, the Y position is never changing, so we're just going to delete this part. Of course, the movement will always move by the speed of the thing. Later, we'll allow the spaceship to move left by changing this 5 to -5, okay? And then, if self.y is bigger than the height, well, we never have to change the y direction, so we're going to delete this too. But here's the thing. If you hit the right side of the wall, this is the right side of the wall, then no longer the spaceship bounces, rather we should make it stick to the right side. So we're just going to say self.x is width minus 20, so that it just sticks to the wall and does not change if it changes, okay? Same thing here. If it's less than 20, we'll just make it stick as 20. So the x should be like that, okay? Alright, so now let's try to draw this. We're going to use Pygame polygon. So let me show you how this is done. Pygame draw.polygon. Yeah, polygon, this thing here. And it says surface, color, and points. Okay, so points are several points of the polygon, and the idea for that is to have a spaceship to have x comma y as the tip of the spaceship, whereas I want the spaceship to have the width of 40 and height of 30, probably 41. So this bottom left corner would be x minus 20 and y plus 30, because the height is 30. The y coordinate will change by 30, whereas x coordinate will be subtracted by 20, and then this other one will be x plus 20 comma y plus 30. So those are the coordinates of the points, and I'm going to provide those as the endpoints, the vertices of the polygon. Okay, so let me pass that along. I'm going to do points equal to, so first self.x, self.y, okay, and then self.x minus 20, comma, self.y plus 30, and also self.x plus 20, comma, y plus 30. All right, so you do this, and those are the points. And let's see, why is it? Oh, there's a y. Okay, I forgot this one. Self.y. Okay. All right, so that's good. And then the surface we're going to draw will be on the screen, and color would be self.color, and the points is just what we just made. Okay, so that will be what we have. And the way we are going to use the spaceship is we have to instantiate it. So right after the ball list is initialized, we'll also make a spaceship instantiated from the spaceship. And we're going to do the same thing down here. So right after the balls are drawn, we're going to move the spaceship and also draw the spaceship. Okay, so now let's see what happens. Save this, run it. Oh, sorry. Spaceship object is not callable. Oh, spaceship.move dot draw screen. Okay. Right. Okay, good. So now let's run it again. Okay, so it already went to the end. Let me run it again. Right. So just went to the right. Okay. Okay, so at this point, I also want this to not just end after a few for loops. So we're going to have a state variable. So we're going to look at the game state. So what we're going to do is right after the number of balls, we're going to define game on as true. That keeps track of whether the game is still being played. And I'm going to put here while game on. So as long as this value is true, then this will just keep being drawn. But I want to make it so that when you click the X on the top right of the window, then top right of the window, when you click the X, then the Pygame will exit. And the way you do it is you first have to look at the event lists in Pygame. So one of the things that Pygame provides you with is, like, not only it allows you to draw stuff on the screen, it also allows you to interact with the mouse or the keyboards. And here's how you do it. If you do for event in pg.event.get, if event.type is pg.quit, and this is when you click the X on the window. In that case, we're just going to do game on equals to false. Okay, so then we can just watch the balls bounce for as long as we want, and it will exit when we press the X. So let's run this. Okay, it just keeps going on and on and on and on and on and on. Okay, and then only when I press this X, it gracefully exits. Okay, so that's already pretty good. Alright, so right now it's not a game because even though we have a spaceship and we have the ball moving, we first have to make the spaceship move left or right, right? So let's make the spaceship move according to the keys. And what we are going to do is right before we show the spaceship, move the spaceship, we want to get the keys that you press. And the way you do it in Pygame is you first make keys equal to pg.key.getPressed. And this one keeps track of all the keys that you've pressed after the last time this is called. So the nice thing is if you don't have such a thing, then if the Python is not running when the key is pressed, then it might not. Sometimes it might not register the key clicks correctly. But this Pygame command just makes every key into a dictionary, whether it was pressed or not, as a dictionary. So let me see if you do. So if I press